my birthday is 4/30/89, but you guys were all born in the beginning of the 2000s, so you're like, oh yeah, 2004, right? Like
914. It have to be a 6. She's talking about
what,
just
a
like
6?
the month and the day. Like so 9 and 14 is the days.
Oh, I thought you meant 2004, which then I was like, wait, you're 16? That doesn't make any sense. That's why she. So wait, then like is Athena? No, I'm just kidding. So I was about to say Athena and Sophia kind of like they need to run for it.
If Athena like dresses up like adult, she looks 21. Like she showed me.
Oh, you should totally pass her, yeah. I mean, we have 7th graders that when they put on like really fancy clothes and stuff, they can pass as high schoolers. Like, it really comes down to how your face develop, like how quickly your body develops and your face matures. And I'm not even sure how to talk about like what, just like you could show people pictures and like estimate ages, and it really is like your face starts looking less childish.
How scary!
Yeah.
How scary would it be to Photoshop Hudson's face onto like a child's body?
we have some 7th graders who could totally do it. Like their Photoshop skills are crazy.
I've seen the Estes pictures in the
Have you seen the Nestis?
Oh no, wait! I've seen that more
Estes in the Nestis.
Oh yeah, I did that, and then Mr. Hudson was on my hand.
Yeah. I photoshopped. So over the summer, I took a Photoshop class, and Mr. Estes was teaching it. So I photoshopped his face onto Elmo.
Oh, that's scary.
All right, so the absolute value function. So head your graph paper, absolute value, and we will then abbreviate it ABS VAL, like ABS period VAL. So anytime after this that we talk about absolute value, we will pretty much just write it like that. Now, absolute value, you guys know, are those vertical bars, right? Like the jail cell or whatever you want to say. And to get through that opening, or to get those bars to disappear, what has to happen to the value? Has to become positive. So when x is our input value, or we could call it our independent variable, then when we say f of x equals, we can think of this graph. Well, if x is 1, y would be 1. If x is 2, y would be 2. If x is 3, y would be 3. If x is 4, y would be 4. If x is 5, y would be 5. But if x is negative 1, y is positive 1. Right? Because it makes it, not parabolas, we're not doing parabolas. It makes it positive. If x is negative 2, y is positive 2. If x is negative 3, y is positive 3. So the absolute value graph in its general generic form looks like a V, please put this on your paper, with a slope of 1 and a slope of negative 1. So this graph can actually be described as a piecewise function. Now piecewise, I'm over teaching here, so get ready. Piecewise is often referred to when we do step functions. And step functions look something like this. What a piecewise graph really means is broken up behavior. This is broken up behavior because each of these are broken, right? We don't connect to the next section. This would be like, how many pizzas do I need to order for my party? If I have up to 3 people coming, I only need 1 pizza. But as soon as that 4th person comes, we'd have to step up and like 4, 5, 6, right? So this would be like 4 through 6, or like 7 through 9. Like, how many pizzas? I can't have a continuous function for pizzas because I can't get partial pizzas. So literally tonight, I will be ordering pizzas for an event, and it will be based on how many people are there, but I can't order partial pizzas. So we could describe this graph as f of x equals absolute value x, which really means y equals x when, so we use a semicolon, what domain do we see the graph of y equals x? What is the domain for that part of the graph? What x values are being used?
Above 0.
Yeah, when x is greater than, and really we could say one of these can have the or equal. They cannot both have the or equal, because then we break our function rule. Remember the vertical line test? Sorry, I just somewhere out of nowhere I just got a headache, so my bad if I kind of trip up on words today or whatever. So negative x, if we already use the 0 here, we're not gonna include the 0 here. It gets included on one of them. It doesn't matter which, but if I make them both equal to, then there are actually 2 points existing at the same location, and that cannot happen. So that is why we do not make them both or equal to. But one of them should contain the 0 because absolute value of 0 is 0. But we don't just work with the parent function, which we're all comfortable with. The parent function is the original, right? And if we're not, let's talk about that for a second. So the parent function of a linear graph is y equals x, right? The parent function of a parabola is, so the parent function of absolute value is just y equals absolute value of x. Then we modify, right? So if we threw these values into our function machine for absolute value, we'd spit out positives, right? Whether it's radical, whether it's rational, whether it's irrational, like a negative pi or who knows, it becomes positive. But
then we don't know if it's 4 or negative 4.
So when we have the output given, I'm not writing anymore. When we have the output given, the input could be positive or negative 4. When we have the input given, the output only has one option. And that is because if we try to look at this, that is, well, I got to shift it up it makes a lot of sense.
There's a negative 3 on the output.
For the y value of 4, this actually traces down to an x value of 4 and an x value of negative 4. So this is not an or situation, it's an and, right? Absolute value of 4 and negative 4 both equal the same output. Is this a function? Yeah, because it's horizontal line, not vertical line, right? So this is still a function, even though 2 inputs equal the same output, because that's okay. It's when 2 outputs equal the same input that's not okay. So yeah, you might want to jot this on your paper. 2 inputs equal 1 output, and that's okay. Because then they don't pass the vertical line test, right? When 2 outputs equal the same input, they fail.
I would always mix those 2 up.
Same. I'm trying to think of a memory trick we could make up. If anyone makes up a good memory trick for remembering what can be a function, let us know, because I can't think of anything right now. Like 2I equals OK. I don't know.
Well, I mean, if you just kind of think of it like, if 2 different recipes create the same thing, then that's fine. But if you do the same recipe twice and it comes out differently, then you probably just don't want to do that recipe again. So it wouldn't be a function.
So Sophia is saying your recipe is the input. If your recipe created one, let's use green line versus black line. If it created this outcome today, but then it created this outcome tomorrow, but I used the same input, that's no good. That's not a functional recipe. I kind of like that analogy a lot. If what you did or what you tried had 2 different outcomes, that's a no-no.
You use the same recipe one day, and then take the second day it's chocolate.
That would be sweet. That's like some sort of futuristic world where it's like a flavor packet that you just don't even understand. So okay, well, we did this, right? If on your now, be careful though. If you want to be accurate, you should have made your slopes actually go up like 1, 1, 1, 1, 1, 1. So if you want to be accurate, Or just make sure you have written m equals 1 and m equals negative 1. Now, similarly to parabolas, we can shift this function. Don't whine, it's the same. It's the same. I'm not teaching you anything novel today. So for each transformation we list, show the graph and its equation, then write the graph in form. So, let's play with these. Or do you want to go back and discuss some possibilities before we try to dissect what has happened here? So, well, real quick, let me make sure we're ready to ask these questions. If I asked you what would, so f of x is absolute value of x, right? So if I say g of x is x minus 2, I'm always tempted to make it a parentheses, and that is not correct. What would this be?
Wait, horizontally with
What?
Right
Is
2.
it 1x or
It's
just
right to
x
because
minus 2?
that negative 2 is an absolute value.
What?
It's
This is
positive.
x minus 2.
Okay. You said
Okay.
1x minus 2
right
and
because-
I left.
Well, there's always 1.
Wait,
Minus is right.
I was just confused
yeah,
about
because
that
it's
one.
Minus
absolute
is right,
value,
plus
so
is
it's
left.
positive.
So you should probably write this down.
Because the x has to count.
So the x is positive.
The reason this is the opposite is when you impact the input. Say your input is 4. Now the output is 2. Right? Here, if my input is 4, now my output, instead of being 4, is actually 2. And when I graph all the points, that actually shifts it right. What? That's a 1, because Sammy
Okay.
was saying she was confused at me saying 1x, and we can always say 1x. So
Yeah.
similarly,
It was confusing.
if we said h of x is absolute value of x plus 7, you go up 7. And also similarly,
Wait.
wait, f, g, h, I. We don't normally do this, but no. Okay, I'm not even going to do that. We don't use I because I is the imaginary number, right? So that's why we don't really call functions I. F, G, H, I, J. I don't care. J of x. What if we did 3? We changed, dude.
It is outside of
It's outside.
It would get skinnier. Press.
So the slope gets steeper. So we call that a compression, right?
Steeper means like it's
More up.
It's more vertical. Yep.
So like the ground isn't as steep, but the like wood thing coming between you is like really steep.
So here's the trick that is easier to do in absolute values, harder to do with quadratics, and that's why we don't normally do this with our parabolas. If we investigate the slope, it tells us our a. Because realize this j of x, if we go to graph it, would actually graph as, sorry, these brackets should be the other way, but it would actually graph as 3x and negative 3x when we actually graph the lines, right? But split in the middle of the graph. So where they hit each other, we would then delete the bottom parts of the graph because we can't have any negative output values. So again, these would be domain restricted, right? Just like we talked about when we drew the parent function, these would be domain restricted. So knowing all of that, now when we analyze this function, where is this point? 1, 2. If you'd like to draw an XY axis on your paper, you can, but I'm not going to make you because we're just thinking through this together. So this right now tells me, what do you want to call this? Z of x. I'm just trying to think of other letters. I know we're involving absolute value x. Ah, crap. I probably don't want this there yet.
Negative absolute value.
Ooh, hold on.
Outside.
So I was first going to just deal with this, but yeah, it's flipped upside down, so we know there's a negative.
It's -2 because it's a slope of 2. So
Wait, why are you there already? You guys.
Do you want me to
I love-
pretend like
no.
I'm dumb?
I want to do this first since we already talked about that.
Oh.
What does this do to my function over here?
okay, so it's the inside the absolute value. It's -2.
Plus
That's why I wanted us to stop and do one piece at a time. This went right 1 up 2.
Yeah.
To go right 1, we go right 1. And guys, this is when I started making my ones like this. When I got, quite frankly, very mad at absolute value bar versus 1. Like, seriously, I would go back and look at my homework and be like, I don't know what this is. So I just started making my 1s like that and my 7s like this. It helped me. So for what it's worth, if you want to start making 1s like that with absolute value, it gets complicated.
And then we have to add.
And then we have to add 2 for that vertical shift.
Oh, I thought she said something else.
Yeah, for that.
No, because when you're doing eraser, then he said shift. I was like, wait. Because like you
Right.
screwed up on the eraser, and then you're.
I may not filter a lot of like these things I tell you. Like I'm just straight up honest and probably too honest with especially you guys. But I do filter the language I say. Now, for what it's worth, apparently studies have shown that more intelligent people are not only disorganized, but they use swear
Found
words.
it. It was okay. How did it get
Was it right?
the whole time?
It was in front of you the
I
entire
put it in my
time.
old homework section.
It was in front of you the entire time.
I still had to get his packet back. Let me know erase this stuff out of it.
Gotta celebrate, right?
Let me know erase.
Go!
Let me do erase the stuff.
No, it's fine. Woo! Alright, okay, moving on. Let's now, instead of my slope being -1 and +1 here, the slope we can see here is, well, over 1, down 2. Crap, so that tells me my slope is -2. Oh, well, that tells me my A. -2. And we're done.
Wow.
It's the same.
So complicated.
I never said it was. Questions?
You're so complicated.
You're so complicated.
Mr. Hudson, so you said that you started changing your 7s.
I
What
like
were your
saying
7s
shift
before?
now.
My 7s.
Yeah, you're like
Oh, just without the little.
They look like the ones.
They were just that. And so if you really want to make a fancy 7, you can do
That's
that.
what I do. I tried doing that. I was able to change my 4s and my 2s, but not my 7s.
I always like
Do you do 4s like that or like this?
No, like the first one.
Yeah,
Really?
those are ugly.
That's too close to a 9.
No, my 9s look like
Yeah.
8s.
You're
Well,
you
then
know,
your
one
9's
time-
too close
one
to
time
it.
you told us how to do
My
this
7s
thing, and
look
it's
like
never-
the-
All right.
And
On
it's
your
like-
own. On your own.
Are you okay? Did you
On your own, create an XY axis and graph.
I love it. Oh my gosh. Oh wow. Who the heck is this fraction? Oh.
Sit on your own, David.
Well, that really just means without me, right? Like it's whatever. I wonder. Right here. And bring your laughter to party with you. Good time. You don't have like a soundtrack in your head when you're solving math problems? No, mine's like Mission Impossible.
No.
I get random musicals stuck in my head.
Yes, agreed. Where is the vertex point of this function? 2, negative 2.
Come on.
So if I use my dotted lines as if they are like my tick marks, so approximately there, is it still going to point up or point down? It's going to point up. What is the slope of those lines? 4/5 or negative 4/5. So we'll go up to 1, 2, 3, 4 over 1, 2, 3, 4, 5, about there. And then we can honestly just reflect that behavior. So if we went up 4 over 5, I mean up 4 over 5, I don't know which is easier in your head. So up 4, 1, 2, 1, 2, 3. And that's our function. Any questions? Oh, there's a couple more. Ah, now that brings up a good point.
What does that mean?
I already got it just by
One x-intercept would be.
So wait, what's your x-intercept?
I got negative 0.5 and then 4.5.
Let's consult the calculator. Wow, this is how we get some confidence here, right? Now, why might those zeros be awkward?
Because the fraction
The
slope.
slope is weird.
It's a fraction slope, so
By the way, if you want to type absolute value bar, it is the key beneath the backspace, but the shift function of it.
is it the given one?
Yes, yeah. Same one that we talked about with that. So then, what was this, -2?
Wait, what do you mean given one?
So when we talked about given, if you were
Oh,
typing,
given.
yeah, it's the vertical bar on the
Oh, I
keyboard.
thought you were talking
It's
about
shift the
like
button under backspace.
I didn't realize you were talking about probability. Okay, this is kind of related. How do you do exponents on like typing them on Desmos?
Shift 6 to do the caret just bumps you up. So if I'm typing y equals x, I hit shift caret and it bumps me up into it, and then I hit right arrow to get out of it.
Wait, how do you figure out the x without graphing it?
But whenever I needed to do that, I just find an exponent and copy paste.
Well, you can also use the
Oh,
keyboard.
yeah, okay.
Oh.
Yeah, don't ever forget that there's a keyboard down here. And then they have some of the basic like functions. All right, so we clicked on these points to investigate them, and we already said this point exists. Why so awkward? Did that? It's not just because the slope is awkward. I mean, I agree. We yesterday were saying like, oh, this is super easy. We can just like, look at the constant and we know what the y-intercept is. But now we've like our y-intercept is not -2 here.
Our y-intercept is when x is equal to 0.
Ah, so if we do algebra, our y-intercept is when x is equal to 0. So this function is, and we can call it f of x, it's okay. We don't have to just use f of x for the parent function. So 4/5 x, sorry, that's vertical, -2, -2. So if we make x 0, f of 0, please write this so you at least have one example of it on your paper. 0 -2, crap, not +2, -2. I do say crap, I don't say the other word here.
What? There's another word?
When you thought I said
Oh.
shift.
HT.
Oh, shift.
Like, no, because like you were writing and you had your eraser on, so you messed up, and then you said shift, and I was like,
I know. But I say crap. That's, I don't care to say
I
that.
don't think most people say
So,
I
this,
was like, oh crap.
here's the problem. When x is 0, unlike in a quadratic, where x is part of the x squared, and x is part of the bx, and it like wipes out all of that, that doesn't happen here. Because x is not a multiplier. right? In quadratics, x is a multiplier. Everything becomes 0 with it. Here, just like in a linear function, x isn't a multiplier. Well, actually, almost different than a linear function.
Are we allowed to solve it yet, or do you want to talk more about it?
Whoa, sassafras, we're about to solve it.
Last time you weren't really excited that we were.
So we need to apply absolute value to the negative 2. We get 8/5.
Which is negative 2/5.
So please do not, although these are very similar to quadratics, do not think that this is your y-intercept.
Oh gosh.
Right? Now, the x-intercepts, 4.5 and negative 0.5.
Didn't you do like x is like 0 equals instead of doing f of x, just have it be 0?
Yeah, so if we replace f of x with 0, go ahead and try it on your paper. This is where things get complicated. Miss, is there anything else left today, or can we just do our homework?
I have a life, David. I don't have time.
I never said you didn't have a life. I'm not saying you didn't have a life. I'm just saying that if you don't have time to do anything at home, you should manage your time more wisely.
Sammy goes straight to the
Mr. Allen with his girlfriend.
Okay, for the sake that this is being recorded, Mr. Allen is happily married and does not have a girlfriend. I know, it's a joke he makes.
Oh, right. If his wife watches this video, that'd be bad.
I don't ever think that Mrs. Allen is going to watch a high school math 2 YouTube video. So we can start manipulating this with algebra, right? What's the first thing we could do? Add the 2.
And then divide by 4/5.
Ooh. Yes, but no.
Yes, but no.
We don't multiply by the reciprocal. So multiply by 5/4.
It's the same thing.
It is the same thing, but it's way easier to think about. So this becomes 10/4. I mean, we could just leave it as a fraction for now.
And x minus 2, which is 0. Oh, it's the same answer.
Why did we do this?
Now, but wait. We have 2 x-intercepts.
So you just say, do you like, how do you divide absolute value by this?
Wait, you have to multiply 4 then?
Divide it by the absolute value of 1 so you don't do it against Couldn't you just pretend that x was positive and figure out what that is and then just no, you can't.
Hold on.
No, you do both
Hold on.
possibilities.
So here, the input thing,
What in the world?
we said, might be 4, but it might be negative 4. The thing in the absolute. So that's what we do. A couple of you have said it kind of quietly of like, can we or do we? So when we get to this point, we split. And I want you to show on your paper that we literally take this equation and we write it out twice. The first way that we write it out, well, actually, first versus second doesn't really matter. One is keeping, I don't know why like 4 different people are talking and there's only 5 of you. We keep it essentially exactly how it looks, except for take away the absolute value bars. Here's where it gets tricky. When I explore the negative option, what then am I going to write on the right-hand side?
I thought you did like the negative 10/4, so it's like x minus 2.
That's why we do that. So, 2 options for the opposite option. Give me eyes. Like, because I want to show you the, like, why we do what Sophia is describing versus, there's another way, but there's a reason we don't normally take that way. If I'm exploring the opposite of what this thing was, I would apply the opposite to what that thing was. But that has to distribute, and this would then become negative x plus 2. A lot of people make a mistake right here. They make the x negative, but they carry down the constant, forgetting to flip its value. So instead, if you want to make your life easy, another option you can take, because all we're trying to do is apply a negative, is apply it over here and just say x minus 2. Yeah, because we just need to multiply a side by negative 1. So this is often confusing for people because they're like, but wait, the output can't be negative. That's not what we're doing right now. We're not doing absolute value right now. We're exploring the two possible options of positive versus negative. This is no longer absolute value, right? So don't worry about having a negative. That's fine. So either make the side that's alone, has one value, negative, or make everything on the other side opposite. If we explore these options, we should get those x-intercepts.
I got for the one in white, it's
4.5.
And a negative 0.5.
And then x, I'm flipping sides. I'm turning this around. Negative 10/4 minus 2. No, plus. So this is negative 2.5 plus 2 equals just negative half. Yeah? And if we come back up here and check, oh, there we go. So when you're asked to solve an absolute value function, there's almost always two solutions. Aside from if this is on your x-axis, then there's just one x-intercept. That would mean it's only been shifted left to right, potentially modified its compression, but we haven't shifted vertically.
for the vertex to be above the x-intercept, or it have to be going downward?
Not have to, then it just doesn't have x-intercepts.
I'm just wondering if there's a possibility where it doesn't.
If it doesn't have x-intercepts?
Yeah.
Let's hypothesize one. So give me an absolute value function that we could talk about that shouldn't have x-intercepts. X squared?
No, actually. X squared? How is X?
So left or right, what do you want to do? We go left 4? Sure, so we add 4, right? But then what you're saying is go up, right? And I'm not going to add a modifier because it will just make things complicated. So if I make my y value 0, right, that would be the x-intercept. We split. Well, first we add 3. You're correct. Yeah, minus 3.
So it's negative 3 equals x plus 1 and 3 equals x plus 1.
You can't have negative absolute value.
That's why absolute value cannot be negative. This is a bag full of lies. So absolute value can't be, this cannot happen. This, literally, f of x being 0 can't happen.
Then what happened?
What? But they're not. I can write things that are not true.
What does that mean? Does that mean that? Actually, no,
I mean,
it means it's a lie.
man, jokes I want to make but shouldn't.
Okay, good. Do it, please.
So, to me saying I can write things that are not true, the first thing that popped in my head was our president does that every day on Twitter.
Yeah.
No one watches these videos.
You are correct. Nobody watches these videos, so we're all safe. And that's it. That's it. That's absolute value, guys. That is absolute value.
The one time Trump looks on YouTube.
Oh, I'm gonna go watch this teacher from Worthington and see how education's going in the world. Oh, I met the president of the Worthington Education Association, not the person in the Oval Office. Okay, do we have any questions about parabolic shifting or absolute value shifting? Because we have only 3 minutes left. There really, there is a president of our, school.
We're gonna build a great, big, beautiful Perry Middle School and make them pay for it.
It's gonna be the best middle school ever. Better than any other middle school.
And make all those taxpayers meet it.
That's like saying we're gonna build a new, we're gonna build Perry Middle School, but we're gonna get Dublin to pay for it. Dublin will pay for our middle
We're gonna
school.
get a good education system.
Oh, I never tried.
Not a good education, the best education. Better than anywhere else.
Make